Hello, Tom from Every Step Calculus, EveryStepPhysics.com. A calculus problem regarding related rates and a ladder sliding down a wall. Really a right triangle problem. And I'm going to read it here. A 25-foot ladder is leaning against the wall and sliding toward the floor. If the front of the ladder is sliding away from the base of the wall at a rate of 15 feet per second, how fast is the top of the ladder sliding down the wall when the top of the ladder is 7 feet from the ground? Let's do it. Index 8 to get to my menu. I'm going to go down here to average rate of change to save time, because average rate of change is the same thing as related rates. And I'm going to scroll down here to number 9, which is ladder and wall. And we're going to find dy dt, the ladder sliding down the wall, number 4. And the ladder is moving right now on the ground, dx dt. I'm going to choose that. Press alpha before you enter anything in these entry lines here. And it's at 15 feet per second. Alpha 1, 5. 15 feet per second away from the wall. I always show you what you've entered. You can change it if you want to say it's okay. The length of the ladder is 25 feet. Alpha 25. They're trying to make these related rates problem like this with the ladder, that calculus does something and figures out all this stuff, and it's just so marvelous. And I say baloney. 20 years I've been in this. I don't know what it finds that's got any sense to it, you know. And I can do all the problems. I probably would pass the test, you know. So the hypotenuse or the ladder is 25 feet. I say that's okay. And the distance the ladder is from where? It's down the wall. So we got to choose number 2. Y. And we're going to choose alpha 7. So we find x from the Pythagorean theorem. And because x is equal to square root of z squared minus y squared, we put those variables in there and come up with 24 feet for x. And we find dy dt, again using the Pythagorean theorem and placing 25, which is the length of the ladder, into, for z, here's z squared, and when you differentiate a constant like this, it's 0. And of course the derivative of x squared is 2x dx dt, and the derivative of y squared is 2y dy dt. And we add the variables here. 2, 7, and 15. That's x is 7. Dx dt is 15. And 2 for the y is 24. And we're finding dy dt. So we start to do our calculations, etc. And dy dt equals a minus 4.375 feet per second. Pretty neat. EveryStepCalculus.com. Go to my site, buy my programs. You'll love them. Have a good one.